This is 13, day 2, general angles. Most of you guys should actually have all of these useful ones. The first thing on your notes is just what's pi over 6 in degrees. It's 30 degrees, 45 degrees, 60 degrees, pi over 2 being 90. They hinge on knowing that pi is 180, and then you just split it. Like, if you divide by 6, you get 30, multiply by 5, you get 150. Divide by 4, you get 45, times 3, you get 135. And so forth. All right, but those are useful ones to memorize. Very, very useful ones to memorize. What are these radians worth in degrees? And we have some more conversions just to refresh yourself. Convert 50 degrees into a pi rad. To convert 50 degrees into a pi rad, you multiply by pi rads over 180 degrees because you want the degree symbols to cancel. So the degree symbols cancel and the zeros cancel, and we get 5 pi over 18. And now it's a pi rad. Convert pi into a degree. There's one of two ways you can do this. You can multiply it by 180 degrees over pi, or since you know pi is 180, and this is what I usually do, I can just replace pi with 180 degrees and move forward with my life. But either way, you're going to get the same answer here because the pi's cancel, and you still have 180 over 15. And I'm going to reduce that right here. They're both divisible by what, at least 5? 15 divided by 5 is 3. 180 divided by 5 should be, boy, I'm tired, 36. And then we have some more reduction because those are still both divisible by 3. And it's just 12. So it's 12 degrees. I'm surprised I didn't catch on to that quicker. Anyways, 12 degrees. All right. And then you have this one, which blows kids up. It just confuses the heck out of them because it doesn't have the pi symbol. So you have to use a formula. Like you legit have to use a formula. And that's the issue kids have with it. But anyways, it is a radian. So we're going to multiply it by 180 degrees over a single pi radian because we want the rads to cancel. And you more or less have to use technology on these. I mean, you could go old school if you wanted to, and you guys did some of that stuff in 4th and 5th grade, but I'm not going to. So there's 3.56 times 180, divided by the pi, and there you go. She is about 203.97 degrees. Not a hard problem. All right, draw the following radian measures. So you're probably going to have to think in terms of degrees to do this. So we're going to do 2 times 180 over pi. So we got 114.59 degrees. And we're just going to draw that angle. Remember, angles start on the positive x-axis, and then they rotate to its terminal side. And if you rotate through a quadrant, you've covered 90, so you got about 24 left to go. It looks something like that. There's your rotation. And there's theta being 2 rads. All right, negative 3 pi over 4, remember that's going to rotate clockwise. And we should know that that's negative 135 degrees because we have memorized things. We memorized 3 pi over 4. If you're not memorizing, you have to go negative 3 pi is worth 180 over 4, and you have to crank it out. And either way you do it, you get negative 135. Memorization makes you so much faster and so much more capable of connecting dots. That's why I push it. If you're not memorizing, you're not trying. I don't buy the whole I can't memorize stuff either. You just don't want to because it's not that interesting to you. Anyways, we're going to rotate negative 90 and then 45 more. And that's what theta being negative 3 pi over 4 looks like. Terminal, our initial side, terminal side, blah, blah, blah. All right, there's too much stuff in here. So I had this page mostly complete, but then I decided I'd go over it. So you're supposed to find arc length and the area of a sector, and a sector is a slice of pizza. And you may or may not remember how you did this in geometry. Now, when I taught geometry, back in the Stone Age, we set up proportions. we would say the measure of the arc compares to 360 degrees, and I'm going to do right here arc length, as the length of the arc, which is S is arc length. I don't know why they use an S, but that's how it's denoted, compares to the circumference of the circle, 2 pi r. Because I'm talking about degrees to degrees, length to length. Arc length, circumference of a circle, 2 pi r. And that was the proportion we used, okay? Now, we can clean this up and make it look pretty, all right? I know, and you're supposed to know, that 360 degrees is 2 pi. So I'm going to do a little bit of substitution here. The measure of an arc compares to twice pi, as S, which is arc length, compares to 2 pi r. And now I'm going to do that old cross multiplication technique, okay? The measure of an arc is equal to S, sorry, I forgot the 2 pi r. I was thinking about something else. 2 pi r times the measure of the arc is equal to S times 2 pi. And both sides contain twice pi. So r times the measure of the arc, which I'm just going to say theta is S. So here's our formula for arc length. S is equal to r theta. And S again is arc length. That's how you do it. Next up would be area of a sector. And the left-hand side looks the same. It's the measure of the arc to 360 degrees, and we'll just start that off with theta. Theta compares to 360 degrees as the area of the sector compares to the area of a circle, which is pi r squared. Now remember, this is equivalent to 2 pi. So theta over 2 pi equals area over pi r squared. Cross multiplication, theta pi r squared equals 2 pi area. Divide out the pi on both sides, all right? And you have theta r squared equals twice the area. Now divide out the 2. And we get this version of it. I don't like to say theta r squared over 2. I like to say that area is 1/2 r squared theta. Now look at this disclaimer. Because I was using twice pi, it's a radian. Theta is always a stinking radian. So you can go back and use old geometry formulas if you want, or you can use these, which is how I will instruct because we are learning radians. Arc length is r theta, area is 1/2 r squared theta. Sprinkler is rotating through a 30-degree angle. If it is spraying water 24 feet, what is the area of the yard it's watering? Now, unless you just had a horrible childhood, you have probably tried to avoid the water sprinkler. And this one sprays water out 24 feet, and it's also rotating through roughly a 30-degree angle, okay? And what you're wanting to know is, as an adult, how far do I have to actually walk to avoid the sprinkler at all? And I've got to walk in a curved nature. Now they are asking for area. Area is 1/2 r squared theta. The disclaimer is this is a radian, okay? So 30 degrees as a radian. You've been doing your circle quizzes, so you should have memorized it's pi over 6. And then you plug in. Now, some kids struggle with what's the radius. Imagine the sprinkler went all the way around, okay? That's the radius, it's 24. So the area is 1/2 of a 24 squared times pi over 6. And I'm going to do this in exact form here. 0.5 times 24 to the second divided by that 6. It's 48 pi. Let's see, this was feet, square feet. Now, if you're not an exact area person, you can just type it in all as it is. 0.5 times 24 squared. There's a pi, and it was all over 6, which is about 150.7 .80 feet. Square feet, sorry, it's area. At the edge of the sprinkler, what is the length of the spray's arc? So remember, this is arc length. And again, Milbrath doesn't know why, but they use an S, and it's R theta. Same disclaimer, radian. And the radius is 24, and the angle is pi over 6, and 24 over 6 is 4, so it's 4 pi. It's 4 pi, or it's like 13.57 foot. It's probably what it is. Let's see how close I am. Yep, 12. Where'd I come up with 13? 12.57. I was off by a whole foot. 12.57 foot. All right, a three-bladed windmill has a blade length of 120 feet. And windmills are large. There's a three-bladed windmill. Its blades are 120 feet long. And there's my windmill. What arc length is covered during a rotation of 270 degrees? So here's my formula for arc length. It's R theta. Again, radian. So 270 degrees, I know from memorizing unit circle is 3 pi over 2. These are coming from unit circle concepts. I told you this, the unit circle is big. It's going to make your life a lot easier if you memorize the blasted thing. And if I imagine the windmill's rotation, it would be the outline of a circle, right? So the radius is 120, and the angle of rotation is 3 pi over 2. So 120 over 2 is 60. 60 times 3 is 180. And this is arc length, feet, 180 pi foot. How many radians of rotation is required for an arc length of 200 to be swept out? This is pretty simple. That's S, all right? So 200 equals the radius of 120 times theta. And you just divide through by your 120, zeros cancel, and 20 over 12 should be 5 over 3. So this is 5 over 3 rads. It does not include a pi equals theta. Now, it would make sense for you to report this in degrees, okay? And it would make sense for this to be in feet, and to be approximated too, but nobody in this world, you tell them 5 over 3 rads, they're gonna be like, well, yeah, awesome, cool. That's like maybe 80 degrees. Remember, to convert from a radian to a degree, we have to multiply by 180 over pi. No, I was off. It's 95.49 degrees. See? Make sure I wrote that down right. 95.49 degrees. If the windmill performs 3/4 of a revolution, now a revolution going all the way around a circle is a radian of twice pi. It's 360 degrees, right? So 3/4 of a revolution has to be 3/4 of twice pi, 3 pi over 2. Think about your unit circle again. You've covered 3 of the 4 quadrants, right? So theta is 3 pi over 2. That's how I find theta. And I want area. Area of a sector is 1/2 r squared theta. So the area of this sector is 1/2. Windmill blades are 120 foot. And the angle of rotation is 3 pi over 2. That's squared. Let's see what that looks like in Purdy form. 0.5120 to the second power. And the numbers here, not including the pi, are 3 over 2. So 10,800 pi square foot. Now, in the real world, you should probably be telling people what these things are. Maybe not in a math class, but in the real world. About 33,929.20 square foot. 33929. Whoops. And that's it for day 2. Let's see, this lesson will be given on Wednesday, which means tomorrow you have a quiz on Thursday. Hopefully you have your twin 13-1, 13-2.